welcome back to free engineering tutorial on operating system. So in previous video we had discussed about classical problems of synchronization, and this video is also continuation of previous video in which we will discuss about dining philosophers problem. So let me explain what is the problem and then we will come to the solution using semaphores. Okay, so this is the problem in which five philosophers are sitting next to each other on round table, and at any instant they are doing what? They are thinking about their philosophies. Okay. After completed their thinking part, they are feeling hungry and wanted to eat rice. Okay. For eating rice, they need two chopsticks. After getting two chopsticks, they can eat. After completion of their eating part, they can again go to thinking part. Okay, so till now everything is fine. Okay, so thinking is done, eating is done. Okay, now what is the problem behind this whole process? Let's say at any instant of time all five philosophers are feeling hungry. Okay, they have completed their thinking part and all five philosophers are feeling hungry. They will pick their one chopstick. Okay, so for that they have to pick their one chopstick. Okay, again they will pick their one chopstick, and in the same way all are picking their chopstick. Okay, and as you can see that whether they are means at an instant of time all are being hungry, they can't eat at the same time all together. Okay, as you can see that they are not getting both chopsticks. Every chopstick is engaged by the other dining philosopher, or you can say other philosopher, and they are unable to eat the rice, and in the same way they are feeling hungry till the long instant and they will die. Okay, so this is the problem. So how to solve this problem? We will solve this. One simple solution is that we can solve it by semaphores. So each chopstick will be represented by semaphore. Okay, and this process means that philosopher will be treated as a process, and it will check whether these what we can say chopsticks are empty or not, means free to use or not. The same thing we are using in semaphore in reading and writing solution, and producer and consumer solution, in which we are checking whether the thing is critical section is empty or not, or whether semaphore is empty or semaphore is ready to use or not. Okay, so that same thing we will implement here also. So in this way it will check whether both the chopsticks are free to use or not. If they are not free to use, they will wait. Okay, so the third thing which is coming into picture is waiting. Okay, so the philosopher will wait for chopsticks to be free. Okay, so the third thing is wait. Now at the instant when all the means you can say that if this philosopher is trying to eat, it will check that this and this chopstick is empty or not, or free to use or not. If it is not free to use, it will wait. Okay, so in this way as you can see that all the process will put on one or all the philosopher will take one chopstick and it will go for deadlock state. What is the deadlock state? Whether the rice is also means until the rice is also full and they are also hungry, but they can't eat because of some synchronization problem. So the solution for this problem is there can be three solutions. Okay, one thing is we can't what we can say, we can't permit all the process or all the philosophers to eat at the same time. Not more than four philosophers can eat the rice at the same time. So because of that one philosopher which is waiting for eating, it will release one chopstick. This, let's say this philosopher is not eating, it is waiting. Okay, he is hungry but it is waiting for chopstick to be empty. Okay, so this chopstick can be used by this philosopher to eating. After completion of this eating part, he can release the chopstick which is he is holding, like this chopstick and this chopstick. Okay, he can release the chopstick, and same way this process which is waiting for this chopstick will take the chopstick and will eat and complete the process of eating. Okay, after completion, in the same way you can see that all the process or all the philosophers can complete their critical section or chopstick eating part, and then release their chopsticks and release their resources, release their handles, and give the process or give the handle back to the next philosopher. In the same way the things are being done. Okay, let me clear this chaos. Okay, 1 minute. Yeah, again. So so this was the first solution which we can implement. The other solution is we can uh, put the symmetric solution. Okay, so what is the symmetric solution? Is that in symmetric solution, each odd philosopher will take its left chopstick first and then take right chopstick. Okay, so let's say we give the number 1, 2, 3 and 4 and 5. Okay, so each odd philosopher will take their left chopstick first and then hold their right chopstick. Okay, so let's say this is the odd. Okay, so it will take firstly its left chopstick, then it will put or hold its right chopstick. In the same way, if all are doing in the same way, you can see that this even philosopher, it will hold their right chopstick. Sorry, this is the left, so it will take or it will hold their right chopstick. If it is not empty, then it will wait. Okay, so if it is using by if it is being used by this processor or this philosopher, so it will wait, no problem. So in this way you can see that all the chopstick are being utilized by only equal number, or you can say that particular number of philosophers, and the eating is being done. Okay, the third solution is simple, is that uh, until both chopsticks are not free, we will not pick up any chopstick. Okay, so if this chopstick is not free, this process will or this philosopher will not pick this chopsticks too. Okay, so there are two chopsticks. If it is not empty, he will not pick up this chopstick also. So in this way we can solve dining philosopher problem. So the code is here, and it will check whether the chopstick on the left is empty or not. So if one processor or one process or one philosopher is waiting for a chopstick, so in this way it will wait, it will take one chopstick, then it will take its other chopstick. Okay, and then he will eat. After eating, he will release its first chopstick, and then again it will release its second chopstick, and now he will think. Okay, so in this process you can see that three phases of one is waiting, eating, and thinking is being utilized in a perfectly synchronized manner. So this is the solution of dining philosopher problem. Now in next video we will discuss about monitors. Till then, thank you.